Okay, in this question, we are asked what is the primary species in a solution at the halfway point in a titration of ammonia with hydrobromic acid, HBr. Okay, so first of all, what do we mean by species? Well, in chemistry, we use that word pretty generically. It can be an ion, it can be a molecule, it can be an atom. It's just some sort of chemical entity. And we are asked what is the primary species in a solution at the halfway point in a titration of ammonia with HBr. Well, perhaps a good way to answer this question would be to draw just a simple titration curve where we plot the pH versus the volume of HBr that we're adding, and we'll say that the pH of 7 is right there. Now we're starting off with ammonia, so that's going to be a pH greater than 7, so we'll start off with something about right there. And then as I add more HBr to it, or add some HBr to it, the pH is going to go down, kind of flat at first, but then it's going to really start to slope down, and then as I go past the equivalence point, the pH flattens out again at a low level. All right, and so we know that on our pH curve, this in the middle here, where the slope is the greatest, that kind of represents the equivalence point. Okay, and by definition, the halfway point is, well, it's about halfway to the equivalence point. So the equivalence point, or the halfway point would be right there. That represents about where the halfway point would be. And if you think about what's going on, while we're doing this titration, we have ammonia, NH3, and we're adding to it this strong acid, HBr, okay? So because this is a strong acid, this is going to be a one-directional 100% reaction, and that hydrogen is going to pop off and add to ammonia, because ammonia is a weak base. So we're going to produce ammonium ion, aqueous, and we're going to be left over with the bromide ion, aqueous. Okay? So this is our weak base, and this would be the conjugate acid of that weak base. And so at the equivalence point, by definition, what that means at the equivalence point is I've converted all 100% of my ammonia into the ammonium ion. Well, at halfway to the equivalence point, that means I've converted half of this ammonia into my ammonium ion, its conjugate acid. So at the halfway point, we have a mixture of that, and that is option D. Okay, and if you remember, that also plays into what I know about that region of the pH of the titration curve. That's what we call the buffer region. Okay, and by definition, a buffer is when you have a mixture of a weak base and its conjugate acid. So that makes sense.